First of the three major formulas we're going to tackle this week is the slope formula. All right, so think for a moment, pause the video if you need to, and think about what you know about the slope formula and maybe fill it out on a piece of blank paper. And then hopefully that'll give you some ideas that you can use to fill out the slope formula line in the sheet. All right. So if you had some trouble thinking about what we know about slope, you might think, well, I know that we use the letter m to be the variable that we talk about for slope. You might remember things like a formula like y equals mx plus b. Uh, this is not the slope formula. This is what we call the slope-intercept form of a line. Okay, so we can give an equation of a line if we know its slope and its intercept, but that doesn't help us calculate what the slope is. All right, so that is not going to help us today, but if you were thinking about that, that's a good thought. You might have thought that the slope is, if you go back to middle school and think about the formulas for calculating slope, there's the fancy formula with all the variables in it, but there are also a couple of different ways that we thought about it. You could think about it as two words, both of which start with R. Can you remember what that is? Slope is equal to r over r. Rise over run. So if I've got 2 points and I want to find the slope between them, I think about how much we're rising, and then we divide it by how much it's running to the right. Okay? And so the rise is talking about, if we're talking about coordinates, we're talking about the change in the y coordinates. And when we talk about change in y coordinates, another thing you may remember is you may remember change in y coordinates being listed as a triangle y. We read this as delta y. Delta is a letter in the Greek alphabet like pi is. And then the run, this is the change in the x coordinates between the two coordinates. So you might think that the slope is rise over run. That might help you think that it's delta y over delta x. And delta is the difference between two things. What's the calculation we use when we have two numbers and we want to know what the difference between them is? If we want to know the difference between two numbers, we should subtract them. All right. And so those are kind of all the clues that you put together. So our numerator is y2 minus y1, the change in the y values, and the denominator is x2 minus x1. That's the change in the y and the x values. All right, so here in this box, I want you to put the slope formula just like it is here. As far as how you can remember it, you can put down some or all of this or something else. The idea is I want you to give yourself some hints for how you could come up with this formula if you didn't know it, but all you knew was what was in this box. Because someday you're going to have a blank sheet of paper and you're going to need to come up with this formula. So how would you remind yourself of how to do that? All right, so fill that in. I don't want you to leave it blank, even though I will. And what it's useful for is that this can help you figure out if two lines are parallel or if they're perpendicular. Okay? What was the rule? If you knew the slope of two lines, how could you tell if they were parallel? Another way of thinking about it is if I gave you a line like this and told you that its slope was 2, and then I gave you a parallel line, what would the slope of that parallel line be? Well, it would also be 2, right? Because these two lines are going in the same direction. They're both equally steep. So if we calculate the slope of two lines and they're equal, then the lines are parallel. And perpendicular, which means that they're crossing at right angles. So think about it. If I've got two lines that cross at right angles, if one of them has a positive slope like this one, the perpendicular line would have to have a negative slope. In the same way, the other way, if this has a negative slope, the perpendicular would have to have a positive slope. It's going in the opposite direction. So slopes are negative, which means they have different signs. And the other thing is that if this line is really steep, this line is going to be kind of gentle. So if this slope is a big positive number, this one is going to be a pretty small negative number. Okay, so for instance, if the slope of one line was positive 5/3, the slope of the perpendicular line would be negative 3/5. Okay? And so we say that those are negative reciprocals. So that gives us some great plans for figuring out if lines are parallel or perpendicular. So when we were doing this earlier in the year, when we were making proofs, we were thinking about alternate interior angles. We were thinking about corresponding angles. We were thinking about other angles like that. But when we've got coordinates, we've got a different strategy for being able to show if two lines are parallel. We're going to be able to take the slopes of both of those lines and just see if they're the same. If they are, the lines are parallel. If they're not, the lines aren't parallel. Nice strategy. In the next two videos, we're going to go on to the other two lines in this form.